In this video, we're going to be doing problems that are similar to questions 1, 2, 3, and 4 in homework 10.3. They all utilize something called the product property for radicals or for roots. Radicals and roots are the same thing. And this is what the property says. Product is a fancy word for the answer to a multiplication problem. And if you have two numbers multiplied together underneath a root, you can take the root of one and multiply it by the root of another. And this is helpful in simplifying radical expressions where we don't have perfect powers of the root. For an example, 75, square root of 75 isn't a counting number. But 25 is a factor of 75. 75 is 25 times 3. And now I can use my product property and say this is equal to the square root of 25 times the square root of 3. And the value of that is that I can simplify the square root of 25. It's 5. And then this times the square root of 3 is just 5 times the square root of 3. The square root of 3 doesn't have any perfect square factors other than 1. You can leave it like this or just write 5 square root 3. We often say 5 root 3. Right? So the game that you're trying to play here is you're asking yourself, what is the largest perfect square factor of 75? Let's write that down. And the reason why it's a perfect square is because we're taking square roots. Right? So if we think about perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. 25 goes in evenly to 75. All right, so you don't want to just factor 75 any old way. You want to factor it so that we've got a perfect square factor right there. Let's do another example. Okay. How about the square root of 8? Again, since these are square roots, I'm asking myself what perfect square goes in evenly to 8. These are all my perfect squares. There's more of them, of course. You can see that 4 divides in evenly to 8. 4 is a factor of 8. So I can write 8 as 4 times 2. And now use my product property of multiplication. This is the square root of 4 times the square root of 2. And we can simplify the square root of 4, it's 2, and 2 times the square root of 2 is just 2 root 2. You don't have to write the multiplication. All right? So 4 was that perfect square factor that divided in evenly to 8. The problem that we did before, 25 was that perfect square factor that went into 75. Really, this is the only concept in examples 1 through 4, but they can be a little bit more involved if we don't have a familiarity with perfect squares or perfect cubes, if we're doing cube roots, or perfect powers of 4, if we're doing fourth roots, etc. So I'm just going to do a handful more examples. How about the cube root, in fact, let's do one more square root and then we'll do a cube root. How about the square root of 40? Right? So square root of 40, 4 goes in evenly to 40, and 4 is a perfect square. And I can square root across products, that's the square root of 4 times the square root of 10, and the square root of 4 can be simplified, it's 2, and the square root of 10 we leave alone. Why? Well, none of these green numbers here, except for 1, divide in evenly to 10. And again, there are more perfect squares. We can keep going. You know, 6 squared is 36, etc. All right. So now we just did the square root of 40. What about the cube root of 40? Okay, so now I want to factor 40 differently because we're taking cube roots. The game that I'm playing is what perfect cube divides in evenly to 40. Let's get some color. And by this we mean is a factor of 40. All right, so let's write some perfect cubes. 1 cubed is 1 times 1 times 1, which is 1. 2 cubed is 2 times 2 is 4, times 2 is 8. 3 cubed is 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. Let's just do a couple more. 4 cubed is 4 times 4 times 4, which is 16 times 4, which is 64. And how about we stop here? 5 cubed, 5 times 5 is 25, and then 5 quarters is $1.25. Okay, so here are some perfect cubes. Of course, there are more. So, of these numbers, I see that 8 goes into 40 evenly. So I'm going to go ahead and factor my 40 as an 8 times 5. Why? Because 8 is a perfect cube. Then I'm going to make use of my product property. This is the cube root of 8 times the cube root of 5. And the cube root of 8 is 2. Why? Because 2 cubed is 8. 2 times the cube root of 5, we can just write it as 2 cube root 5. You don't need the multiplication there. So notice how in the problem before looked so similar, but they were different questions. Here we were taking a square root, and here we're taking a cube root. So although the number underneath the radical was both 40, I factored it differently. I factored 40 here into 4 times 10. Why? Because the square root of 4 is 2. 4 is a perfect cube. Right? That was the value of that piece. On this one though, I factored 40 into 8 times 5. Why? Because 8 is a perfect cube, and we were asking for cube roots. So before you jump in, let's fix that a little bit. Before you jump in, make sure that you read the little small number right there first. And if there is no small number, that means it's a square root. I think I will go ahead and do one of these problems. Let's do problem 4. But you guys have the concept for doing an infinite number of problems like this, right? We look at the small number here, and then you say what number times itself that times what will evenly divide into the thing here. And that's the way that you want to factor this, okay? So let's pull one up from the homework. All right, so we're going to do problem 5 here from the homework. This one now is a 4th root. So the game that we're playing is what perfect power of 4 is a factor of 243, divides in evenly to 243. All right, so I'm going to write perfect powers of 4. 1 to the 4th, 2 to the 4th, 3 to the 4th, 4 to the 4th, maybe even 5 to the 4th. Of course, there's more. Could keep going on. 1 to the 4th is 1 times itself 4 times, which is 1. 2 to the 4th is 2 times 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8, times 2 is 16. 3 to the 4th, 3 times itself 4 times, which we can see is 81, right? We got a 9 times 9. You can use a calculator on these. 4 to the 4th, 4 times itself 4 times is 256. 5 to the 4th, 5 times itself 4 times is 625. So the 1 doesn't help terribly much, but why did I say that? 1 times 243, the 4th root of 1 is just 240. The 4th root of 1 is just 1 times the 4th root of 243. Oh my goodness, I haven't even changed anything, right? So that was just anecdotal. When I said the 1 didn't matter really so much, that might have been a little confusing, but that's why. What numbers here are going to divide in evenly to 243? So I'm just going to get my calculator out. 243 divided by 16. Oh, didn't divide in evenly. 243 divided by 81. Beautiful. 3. So 243 is 81 times 3. And the reason why I'm factoring it that way is because 81 is a perfect power of 4. Now I can use my product property and say this is the 4th root of 81 times the 4th root of 3. The 4th root of 81 is 3. Why? Because 3 to the 4th is 81. And the 4th root of 3 is just the 4th root of 3, and we're done. Let's go ahead and put that answer into our calculator. All right, so I'm going to come into my answer field here, and my answer is 3 times the 4th root of 3. So I'm going to go ahead and put in my 3, and to get that 4th root of 3, I'm going to use my arrow. And then this root right here is square root. You see there's no number right there. But here, this root is the nth root, meaning I can put in any number up there. It defaults to a 3, but you can come back there and put in any number you want, and I want 4 because I want the 4th root. Save. Looks beautiful. 3 times the 4th root of 3. And then I'm going to go ahead and hit submit. And we did great. Now these little part in the directions, when it says use SQRT for square root x or square root any number, it's telling you that you could just type that in right here. But I think it's easier if I just hit the yellow arrow and pick up that square root symbol. Similarly, right here they're giving you the directions for how you would type the xth root of y. So here, notice we have our 3, and then how did they put in the 4th root of 3? Like that. And that's how they're telling you this. The root is the number that you write first, and then the stuff underneath the radical is the number you write second. That's perfectly fine if you want to type that shorthand in, but I think using this little dialog box, that little yellow arrow, is a little bit easier. Okay, this concludes this video on questions 1 through 5 in this homework.